All right, today we're going to be doing our 8.5 notes. And I want to remind you, anytime you're watching this video, you're welcome to pause and go back if needed in order to make sure you're understanding. So today we're going to be using Desmos while we're doing our notes. So that is why I have my dual screen up. And everything we're doing for our notes is going to be using Desmos. So the steps are there. It says go to Desmos bookmark. Now, if you do not have Desmos bookmarked and you're on a Chromebook at school, you can press the WISD bookmarks and it is there. Otherwise, just make sure you are on the desmos.com/testing/Texas/graphing. If you're on a different computer or on your phone, and make sure it has the green bar that says grade 8 EOC math, because this is the Desmos you'll be able to use for STAR. So first, on the top left, hit the plus button and click the table option. Then you're going to type all your X's in the X1 column. So remember, your X's are your first of the two in an ordered pair. So I have -6, -4, -3, and +3. So these are each of my X values. And then enter your Y values in the Y1 column. So this is your second part of your ordered pair. So I have 42, 10, 0, and 24. Now, Desmos has a really cool trick to it. If you click the little magnifying glass next to the table called Zoom Fit, it makes all of your points appear. Now, we're going to adjust our graph window. You could either drag around or click the little Zoom Fit button. And then under the table, we're going to start another line. Now, because we know we're working with quadratics and trying to create a parabola, we need to think about the quadratic equation. Somewhere on your page, it would be helpful to write y equals ax squared plus bx plus c. This is your quadratic equation, and it's also available on your STAR reference sheets. Now, on Desmos, if we type ax squared, to get squared, you can press Shift-6. It's that caret button to get the 2. Or you can use the little keyboard in the bottom left-hand side of Desmos. Then I'm going to click my arrow to go out of my exponent and type plus bx plus c. Now, you'll notice nothing happens and there's an error. That's because when we're talking to Desmos, it's like talking to ChatGPT. We need to give it as much information as possible. And because in my table it says X1 and Y1, I need to tell Desmos that I need to use Y1 and X1 from my table. Now, the Y1 disappeared, don't panic, and that's because I also have an equal sign. So because Desmos is a computer or a tool, we need to tell it, connect these dots approximately. So I'm going to delete my equal sign and do a tilde. So now it looks just like you see it in the notes. Y1 tilde, that's the little squiggle symbol, ax1 squared plus bx1 plus c. So I'm telling it, take x1 and y1 points from the table and connect them. Now, if I scroll down, it gives me the a value, the b value, and the c value. So I'm going to write my equation with that a, b, and c value. So y equals, a is 2, so 2x squared, plus b, which is 4x, plus c, which is a -6. So instead of doing plus a -6, I'm going to do minus 6. So y equals 2x squared plus 4x minus 6. Now we're going to do the same thing. If you'd like, you can just make these line and table invisible, but instead I'm going to clear them out to move on to the next one and start a fresh table. So I'm going to put in my y value or my x values, -8, -5, -2, +4, and +6. And then I'm going to put in my y values, 9, 13.5, 9, -27, negative 47. And if at any point you feel like it's not making sense, just go back and double check that your negatives are there, that the right x's line up with the right y's based on the ordered pairs, and so on. Now I'm going to press the zoom fit button again so that I can see all the points. And I'm going to type in y1 tilde. Remember, shift and the tilde is right next to the number 1 button on your keyboard. So shift and that button next to the number 1. Ax1, shift 6 to get my squared, and use the arrow to click over, plus bx1 plus c. Now it's connected all my dots. Now, really cool feature is we can also see our zeros or our x-intercepts and our y-intercepts very clearly, just like we can when we just draw a line. So even though it's now connecting points, it will also tell us the important points. So our a value is negative 0.5. So we're going to have y equals negative 0.5 x squared. And our b is negative 5. So we're going to do minus 5x and plus 1. Okay. Now I'm going to clear this out again, or I could leave my equation and just clear my table and start another table. Now you'll notice that it says x2, y2. I can just switch this to x1, y1 so that it connects to this equation. Otherwise, I have to switch the ones in the equation to 2. So there's one of 2 ways you could do that. You could clear the whole thing and retype everything, or add a new table and just change it to x1, y1 again. So my x values are negative 3, negative 2, 0, and 3. My y values are 4, 1, 1 again, and 16. Now, I still want to be able to see all my points, so I'm going to press the magnifying glass for zoom fit. And you can see them all here, and it's giving me my a, b, and c value. So my a is 1, so it's y equals, I could write 1x squared, but I don't need it, so I'm just going to write x squared. My b is 2, so plus 2x. And my c is 1, so just plus 1. All right, and again, if I click this line, I can see my x-intercept, my y-intercept, and my vertex. All right, so the next problem says the concentration in milligrams per liter, that's what the mg/L stands for, of a medication in a patient's blood as time passes is given by the data in the following table. Time, or my hours, is going to be my x value, and the concentration is going to be my y value. All right, so we know that our time is our x value because remember the x is an independent variable and the y depends on the x. So time passes regardless, therefore it is an independent variable and is our x variable. So we need to, again, use the table feature of Desmos and type in our points. So x's are 0, 0.5, 1, 1.5, 2, and 2.5. Our y values are 0, 78.1, 99.8, 84.4, 50.1, and 15.6. Now, to be able to see all my points, I'm going to press zoom fit, and you can see a little bit of that parabola, and we're going to use our quadratic function, y1 tilde a x1, use the caret button, squared, plus bx1 plus c. So now it's connecting the dots, and it is approximate. So this is like a trend line. So the equation is going to be a is negative 56.2143. Well, we're going to round. So I'm going to say y equals a, I'm just going to say negative 56.2 x squared. B is 139.3, so plus 139.3x plus C, which is 9.35, I'll round to 9.4, plus 9.4. Now it says, when is most medicine in the patient? So remember, your medicine is your Y value. So when we're looking at our Y value, I see that 99.8 is the most medicine in the patient. So 1 hour would be the time, the when. So 1 hour. When is the biggest amount of medicine in the patient's system? Or what is the biggest amount? And again, that is 99.8. And I'm going to use my label of milligrams. When, so we're looking at time again, is the medicine completely out of the patient's system? So looking at my graph, my x-intercept here, excuse me, is about 2.5. So at about 2.5 hours, or a little bit after, is the patient out of this, or the medicine out of the patient's system? And then what is the concentration of the medicine in the blood after 4 hours have passed? Well, after 4 hours have passed, this is past 2.5 hours, so there would be no medicine left. No medicine left. All right, now example 2, a table shows the relation between the speed of a car and its stopping distance. So speed is mile per hour, stopping distance is feet. And again, we have to recognize that our x value is the independent variable. So our speed is independent. The stopping distance is affected by the speed. So our speed is our x and our stopping distance is our y. So again, we are going to put these points in the table. Now, here's another option. You can go ahead and delete the information that you had in your table and just write the new information. So 35, 45, 50, and 60. And then our y value is 96, 140, 165, and 221. Now I can't see the points, so I'm going to press zoom fit. And now I can see all of the points. And you'll notice they're all in the positive because you can't travel a negative miles per hour and you can't stop in a negative amount of feet. So we're only focused on the positives of this parabola. So our A value is 0.04. So y equals 0.04 x squared. Our B value is 1.2. And our C value, is 5. Now it says predict the stopping distance for a car traveling at 65 miles per hour. So 65 miles per hour is going to represent your x value. So we are going to write out our equation, but instead of writing x, think about it like a function. F of 65 equals, we're inserting 65 for x. So 0.04, x is 65 squared, plus 1.2 times 65, plus 5. And we don't need to do this in our head. We can type it out in Desmos in order to solve. So we're going to go to, if I can click further down, let me see. There we go. I'm going to type 0.04 parenthesis 65 parenthesis squared plus 1.2 parenthesis 65 parenthesis plus 5. 252. So the estimated stopping distance is 252 feet. All right, now we're going to practice graphing and getting our quadratic equation. But number one, actually doesn't really make sense as a quadratic. So we're going to, excuse me, if I can click away. Oh, goodness. All the sounds. Okay. Oh my gosh. There we go. All right, we're back to business now. So I'm going to get rid of this number 1. And we are going to practice doing these next two. So add a table. Your x values are your first number in your ordered pair. So -4, -1, 3, and 8. Your y values are -17, -7.25, -1.25, and -5. Now we're going to type our quadratic equation, y1 ax1 squared plus bx1 plus c. Our a value is -0.25. Oh my goodness. So y equals -0. No, it doesn't want to cooperate. 0.25 x squared plus b, which is 2x, plus c, which is -5. Well, actually, I don't need the plus there because it's a -5. So I could just write -5. Now I'm going to do the option where I can just delete my data and insert my new data for my next one. It just saves me the time of having to type the equation again. So -8, -6, -5, -1, and 2 are my x values, and my y values are 163, 32, 5, -53, and 16. Now, because I already have this equation here, I notice that they're kind of odd numbers, but I'm just going to round to the nearest tenth again. So my a is 4.8, so y equals 4.8 x squared. My b is 16.6, so plus 16.6x. And my c is -37.76. The 6 tells the 7 to round up, so -37.8. All right. Now, a pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see who can catapult, or whose catapult will send pumpkins the furthest. One catapult launches pumpkins from 25 feet above the ground at a speed of 125 feet per second. The table shows the horizontal distances in feet the pumpkins will travel when launched at different angles. So I'm going to, again, just delete the information in my table to save myself from having to retype the equation and insert my x's and y's. Now, the angle is going to be your x because that is your independent variable, and the distance depends on that angle, so that would be your y. So 20, 30, 40, 50, 60, and 70. And then we have 372, 462, 509, 501, 437, 437, 323. All right, now I'm going to zoom fit because I want to see what this looks like when a pumpkin is catapulted. And thinking realistically, again, I can't have a negative degrees, right? I'm not going to catapult the pumpkin into the ground, and it can't travel any further. It can't travel a negative distance, right? And it's going to stop when it hits the ground. So here, just in the positives, is where my pumpkin is being catapulted. So my a value is -0.261429. We're going to round again. So I have y equals, we're going to say -0.3. 3x squared. And our b, we're going to round to 22.6, so plus 22.6x. And our c, we're going to just write 23. plus 23. Now it says, what angle made the pumpkin travel the farthest? Well, when we're looking at our angles and we're looking at points on our graph, we want to see which one makes it travel the furthest, and that's our y value. So looking at your vertex, 511 would be your largest distance it traveled, and that would be at 43 degrees. So you could estimate just by looking at this table about 45 degrees. And looking at our parabola on the on Desmos, we could even be more specific and say at 43 degrees. Now it says the following data represents the average maximum and minimum temperatures recorded each month in Raleigh, North Carolina over a 6-month period. The temperatures recorded are in degrees. So predict the minimum temperature if the maximum temperature is 90, and predict the maximum temperature when the minimum temperature is 40. All right, so we're going to graph this information again. And I'm just going to delete. Just saves a little time. And I'm going to put my x in as my maximum. So 72.3, 79, 85.2, 88.2, 87.1, and 81.6. And I'm going to put my minimum temperature in for y. 46.5, 55.3, 62.6, 67.1, 68, and 60.4. All right, I want to see all these points again very nicely so you can see the relationship between the minimum and maximum temperature. It says if my maximum is my x-axis, okay, I'm going to zoom out for a moment. If my maximum is my x-axis, and it says predict the minimum temperature if the maximum temperature is 90, I'm going to click my line and drag until my x value is about 90. And it says my y value is 69.98. So I could estimate that when the maximum temperature is 90, the minimum temperature is going to be about 70 degrees. Now, when we're looking on our table, that 90 degrees would fall somewhere in there, right? 88.2 is the max. The minimum is 67.1. So we could also just add a little bit on, right? 88.2 is only 2 degrees off of 90. So if we add a couple degrees to our minimum of 67.1, that's about 70. Now it says predict the maximum temperature if the minimum temperature is 40. So now, because I'm looking at the minimum, and the minimum is my y, I'm going to click and drag until my, my y value is about 40. So I would say about here, and my maximum temperature is about 68.6. So I could say about 68. And using the table wouldn't really work because it's somewhere in here, less than 72, less than 46.5. So it's best to use your Desmos, your graph, to predict. All right, last one. The Mongolian horde have commissioned you to build some trebeks in an effort to knock down the walls of their enemies. Since you're so smart and you effortlessly get on Google and you find some blueprints and immediately get to work, your final product is a beautiful weapon of destruction. However, your life depends on its effectiveness. Below is the table showing snapshots of a boulder being flung from your trebek. So we're building this boulder launcher and we're going to make sure that it works. So we've got to figure out if this is accurate. All right, so our distance, again, is our x, and the height depends on the distance. So that is our y. So 0, 5, 10, 20, 28, and 40. And our height is 15, 32.5, 45, 55, 48, 48.6, and 15. Oops. Now, you're going to gather this information, your A, B, and C, and write it as your quadratic equation. So y equals negative 0.1 x squared plus 4x plus 15. Now, the boulder hits the ground when we're looking at our parabola. Oops. If I can click here. All right, there we go. The boulder hits the ground at about 43 feet. The maximum height of the boulder is our vertex, which is 55 feet. And your zeros are where it hits the ground. Now, this zero past the x-axis doesn't really matter because we can't have a negative distance. But our other zero, which is 43.452, is where the boulder hits the ground. So 43.5 is where the boulder hits the ground. Negative 3.5, our other zero, doesn't really matter because it can't travel a negative distance. All right, I hope this helps. And if you have any questions, make sure you ask your teacher. Thank you guys for joining us.